Okay, the next thing we look at is a process of verifying identities. And one of the main functions of verifying identities is to really give us a lot of practice with the basic identities. And I've written up here some of what is considered in trig to be the basic identities. For example, the three Pythagorean identities are basic identities that you need to know. Also note that for each one of these basic identities, each one of these Pythagorean identities, you get a couple of other identities for free. For example, if you know cosine squared x plus sine squared x equals 1, then you also know cosine squared x is 1 minus sine squared x. You just simply subtract sine squared from both sides. Likewise, sine squared x is 1 minus cosine squared x. See, these aren't like separate identities that you just have to commit to memory. They come from this identity, cosine squared x plus sine squared x equals 1. Likewise, you'd get a couple of free ones here. I mean, you'd get tangent squared x is equal to a secant squared x minus 1. Or secant squared x minus tangent squared x. I mean, that's equal to 1. Don't have to commit these to memories. They come from this identity. I mean, if I label these three identities, these three Pythagorean identities as 1, 2, and 3, know those three because they go so far in trig. Other basic identities, the quotient identities. Knowing the tangent is sine over cosine. Knowing cotangent is cosine over sine. I didn't even bother to write the reciprocal identities up here, but those are basic identities as well. Knowing that cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. Cotangent's the reciprocal of tangent. Even and odd identities, those are even considered to be, basic identities. That cosine negative x is cosine x. Sine of negative x is the opposite of sine x. Tangent negative x is the opposite of tangent x. So these are all basic identities, and our whole process of verifying identities is to give us a lot of practice, a lot of experience with these basic identities. Here, I'll show you in a minute an example. All right, here we are, folks, a classic example, classic process. We're going to verify an identity. This is an identity, and we're going to verify that it is true. There are many ways to go about verifying identities. I'm just gonna verbally state the process I go through. It's pretty short and sweet. The first thing I do is I pick one side of the equation, one side of the identity, to do all of my work on. And I'm going to try to do all of my work and get it to match the other side of the equation. The side I try to pick, preferably I'm going to try to pick the more complicated side. Oh, look at this identity. I think the left side is most definitely the more complicated side. There's a lot more junk over here on the left than on the right. So my game is I'm going to do stuff on the left side of the equation and try to get it to match the right side. So a habit that I've developed is I draw a vertical line down from the equal sign, and I'm doing all my work over here on the left side, and I want to try to get it to match the right side. So let's look at the left side here. I got a tangent squared 4x plus a cosecant squared 4x minus a cotangent squared 4x. And I was like, well, where to begin? Hey, those basic identities I just reviewed. I see a Pythagorean identity here. I see Pythagorean identity number 3. The one that I called number 3 was 1 plus cotangent squared equals cosecant squared. One plus cotangent squared equals cosecant squared. Let me write that up here real quick. 1 plus cotangent squared equals cosecant squared. Look at this right here. If I subtract a cotangent squared from both sides here, I have a cosecant squared minus cotangent squared. Now the fact that the Pythagorean identities have x's in them, and in this identity I have 4 x's, is absolutely irrelevant. And what I mean by irrelevant is I could replace, in the Pythagorean identity, I could replace each of these x's with the 4x, and it's still true. So what I have right here is nothing more than 1. This is the number 1. It's from a Pythagorean identity. Now look what we have. Tangent squared 4x plus 1. That's another Pythagorean identity. Look at what I called Pythagorean identity number 2. It said 1 plus tangent squared equals secant squared. Well, I have tangent squared 4x plus 1. That's the same thing as 1 plus tangent squared 4x. I mean, addition is commutative. So that means this is a Pythagorean identity. And we know 1 plus tangent squared is secant squared. And that is the right side. I am done. I have verified this identity. There's nothing more to do. And we'll look at another one. All right, here we are. We're going to try to verify another identity. My guidelines are I'm going to pick a side, preferably the more complicated side, do all of my work on that side, and try to get it to match, the other side. It's kind of tough. Sometimes it's kind of tough to determine which side's the more complicated side. And I mean, if all else fails, flip a quarter. Make heads left, tails right. I mean, it doesn't matter if you can't tell. I'm going to pick the right side to do all my work on this one, mainly because the prior one I picked the left side. They both look equally complicated to me. But I can say that on the right side I see immediately how I'm going to start the problem, how I'm going to start the process of trying to verify this identity is true. And that's using a quotient identity on tangent theta. We know tangent theta, well, we know that is sine over cosine. So I could immediately see something to do to get the ball rolling. Well, now I'm going to keep the ball rolling by just multiplying these two fractions together. Remember, this is a sine theta over 1. If I multiply them together, I get sine squared theta over cosine theta. Now I want to keep the ball rolling still. Here's that sine squared. Pythagorean identity. We know cosine squared plus sine squared equals 1. So that means sine squared equals 1 minus cosine squared. I'm just using a Pythagorean identity for sine squared theta. I'm rewriting it as 1 minus cosine squared. And now since I have a fraction and my denominator is a single term, I can split that into two separate fractions. 1 over cosine minus cosine squared over cosine. And now let's try to simplify. 1 over cosine. That's a reciprocal identity. 1 over cosine is secant. And cosine squared over cosine, well, that reduces down to just cosine theta, and that's the left side of the equation. So I did all my work on the right side. I've matched it to the left side. I'm done. I have verified the identity. So hopefully so far in the first two examples I've looked at, you've seen how I've really done nothing more than use Pythagorean identities, quotient identities, reciprocal identities. I mean, it's the basic identities. It's just practice with these basic identities. Let's try another one. All right, hey, look at this one. I decided to use alphas. I was getting tired of using the thetas. So here, our identity is a tangent alpha plus cotangent alpha over tangent alpha minus cotangent alpha plus tangent alpha over cotangent alpha. And that equals cotangent squared alpha minus tangent squared alpha. That's an identity. So my process, I'm going to pick one side to do all my work on. preferably the more complicated side. The side I'm going to pick is the left side. Just fractions involved. That seems more complicated. So I draw my vertical line. And I was like, well, now, where to begin over here? Yeah, here's where I'm going to begin on the left side. This fraction has tangent alpha as a single term in the denominator. So I'm going to take this fraction and split it into two fractions. It's a tangent alpha over a tangent alpha plus cotangent alpha over a tangent alpha. And minus, and I'm going to do the same thing here, but since I'm going to have two terms, I better smack down parentheses so I don't make a careless sign mistake. So here I would have a cotangent alpha over a cotangent alpha plus a tangent alpha over a cotangent alpha. Alright, let's take stock of where we're at right now. Well, that's kind of cool. Tangent alpha over tangent alpha, that's a 1. This cotangent alpha over tangent alpha. Hey, we know cotangent is the reciprocal of tangent. Well, and tangent's the reciprocal of cotangent, if you will. So, thinking that tangents and cotangents are reciprocals of each other, if I think of the denominator, tangent alpha, if I think of that as being 1 over cotangent, then that means this mess here, well, let me write it down. It's cotangent alpha over 1 over cotangent alpha. I'll be able to do something with that in my next step. Cotangent over cotangent's 1. Tangent alpha over cotangent alpha. Again, cotangent's the reciprocal of tangent. So if I write that denominator, this cotangent, as 1 over tangent, I'll be able to do some simplifying now. So here we go. 1 plus cotangent divided by 1 over cotangent. Well, that would be cotangent times the reciprocal of this. So cotangent times cotangent, that gives me a cotangent squared. Distributing the negative, so I have a -1 minus tangent divided by 1 over tangent. Well, that's tangent times the reciprocal. This will simplify to a tangent squared. And now if I just kind of clean up what I have here on the left side, 1 minus 1, well, that's 0. I'm left with the cotangent squared minus a tangent squared, which is the right side of the equation. So I've done all my work on the left side, got it to match the right side, I'm done. I have verified the identity. And notice here, really all I used was, the only trig I used was my knowledge of a reciprocal identity. That's it. The rest was just like arithmetic, algebra. Let's do one more example. Alright, hey, this one, boy, this one's really tough to determine which side's the more complicated side. I don't think it's going to matter which side you say is the more complicated side. What I'm going to show you would work on either side. So I'm going to pick the left side. And I'm going to show you this is a trick, if you will. Let me see if I can find some pinkish colored chalk. The way you're going to do here is you're going to multiply, on the left side, you're going to multiply the numerator and denominator by, it's like the trigonometric conjugate. You're going to multiply it by a conjugate. Now that's a fancy way of saying you're going to multiply it by the number 1, and specifically this version of the number 1. Secant x plus 1 over secant x plus 1. That's just the number 1. So let's check this out. When I take this, and that's by the way, secant x plus 1 is the conjugate of secant x minus 1. Because when I multiply together, when I take this and multiply it by that, if I were to FOIL it out, old algebra, FOIL it out, I'm going to get a secant squared x minus 1. It's like a difference of two squares. Now notice the denominator is tangent x times secant x plus 1. And what do we see in the numerator? That's a Pythagorean identity. We know 1 plus tangent squared is secant squared. So for free, we get secant squared minus 1 is tangent squared. Just comes back to an identity, a good old Pythagorean identity. And you have a tangent squared over a tangent. Cancel one of these tangents with that tangent, and you're left with tangent x over secant x plus 1, which is the right side. And that's it. We have verified the identity. So hey folks, hopefully you've seen in the 4 examples I've done on verifying identities, the process that I'm going through. I pick one side of the identity, one side of the equation to do all of my work on and try to get it to eventually match the other side of the equation. The side of the equation I pick, I try to pick what I feel is the more complicated side. And hopefully you've seen that really what I've relied on for all of these that I've done are basic identities. Pythagorean identities, reciprocal identities, quotient identities. I've just relied on basic identities. And that's what we should be getting out of the verifying of identities. It gives us more work practicing the basic identities. So that's it. Good luck on verifying identities. Thanks for watching.